All right, so we're going to continue graphing linear equations today, but we're going to graph linear equations that have a y-intercept or an initial value. So rather than starting at 0, 0 and using my slope, we're going to start from a different place on the y-axis and start graphing using our slope there. So in this number 1 here on the worksheet, it says y equals 5 halves x minus 4. But in order to help us understand what the initial value is, let's take a look at the equation, but we're going to scratch out the negative 4. Let's just look at y equals 5 halves x. Now, when we start by graphing this, because I crossed out the initial value for now, it starts at 0, 0, right there in the middle of the graph. Then we use our slope 5 over 2 to graph our line. And 5 over 2, when you graph, the top number represents the change in y, meaning what's the like from my starting place, am I going to go up or down? And again, if I go up, that means it's a positive number. If I go down, that means I had a negative number. So that's a positive 5. So I'm going to go up 1, 2, 3, 4, 5. And the bottom number tells me how far I go left or right. And the change is a positive 2, so I go to the right 2. And remember, with graphing, just to make sure I keep all my points on the graph, I tried to as best I can, you can also do a double opposite. So rather than going up 5 to the right 2, like our slope says, we can go double opposite down 5 to the left 2 if we wanted to. Again, if you wanted to continue doing the graph above the grid, you could, but you can also do double negative to keep the graph on the line. The line on the graph. All right, so this is what my graph looks like if it's just y equals 5 halves x. Now let me show you what the graph looks like when we include the negative 4. So y equals 5 halves x equals negative 4. Actually, the graph is going to look very, very similar. Here's the difference. The negative 4 is the initial value of my graph. So rather than starting at 0, I'm actually going to start my graph at negative 4 on the y-axis. And here's the way I like to think about it. Remember in geometry we learned about translations, how the shape doesn't change and the size doesn't change, it just moves around on the graph. Same thing with these lines. The line will look the exact same, the only difference is we've moved it down 4 units. So I put my first dot at negative 4 on the y-axis. But after that, I do everything the same. I use the slope 5 over 2 and graph my line. So I'm going to go up 5 over 2. I'll do it again, up 5 over 2. And I had to go off the graph this time. It's almost unavoidable. And then I draw my line. So notice that these two lines are the same. They're the same line because they are parallel. That's something else we're going to get into in this unit. These are parallel lines because they don't cross each other. Notice how they're running right next to each other, kind of like railroad tracks. They will never intersect or cross each other. And the only difference between the two is that the one in green starts at 0, the one in red starts at negative 4. So my slope is 5 over 2. And that's why I write there on the line. And my y-intercept for this equation, rather than being at 0, it's our initial value at negative 4. All right, let's go and do another example while we're here. Let's look at number 2. So it's y equals negative 3x minus 3. So let's pretend like that minus 3 in the back of the equation isn't there. So we're just graphing y equals negative 3x. Now, because it's just negative 3, I always like to include an invisible 1. It reminds me when I graph my slope that there is a denominator I have to move the graph with. So we start at 0, 0 because I crossed out the initial value for now. And we follow our slope. So negative 3 on top. Remember, the top number tells us if we go up or down to do my slope. And because it's negative, we're actually going to go down. So we're going to go down 3 and over to the right 1. So the negative only affects the number on the top. The negative doesn't apply for the number on the bottom, only the number on the top. So down 3 to the right 1, and I'll do it again, down 3 to the right 1. And so how I went up my graph here, I could have done double opposite from my first point, so I could have go up 3 to the left 1 if I wanted to. So there's my line. All right, so now let's include the negative 3 that we crossed up before. So rather than starting at 0, my graph is going to start at negative 3 on the y-axis. So I start at negative 3, but I do the same exact steps. I'm going to go down 3 to the right 1. And because I'm off the graph, let's do double opposite. I'll go up 3 to the left 1, and there's my line. So notice the same exact line. They have the same exact slope. They're parallel lines. The difference is I just translated the line or moved the line down 3 units. And that's what my initial value does. It just basically moves the graph from 0 down 3, or it could move up. It doesn't matter. So the slope of this line is -3/1, and my starting place for my y-intercept is at -3.